Today we start about some topics about product metric. Product metric. Okay. Product metric is open or not. We start now. We start by this question. This question is now. We write down this question. Let xy be matrix spaces. xy be matrix spaces. And consider the product space x cross y. Consider the product space. Consider the product space x cross y. Okay, with product metric. Consider the product space with product metric. Consider the product space with product metric. Then this metric we know about that in previous class also. This metric is the d1 x1 y1 x to d of product metric d of x1 y1 x2 y2 equal to maximum of this product d1 x1 x2 and d2 y1 y2. Okay, consider this and defines a metric on the product space x cross y. This one is the product metric. At this metric we have to show that any set of the form any set of the form bxr cross byx subset of x cross y is open in x Cartesian product y. Okay, is open in x Cartesian product y. So we start from, and here given hints also. We'll write about these hints first. Hints is that let AB belongs to bxr cross bys. Okay, and then we have to find epsilon greater than 0 such that VAV comma epsilon subset of bxr Cartesian product bys. Okay, and then any epsilon less than minimum r minus d of ax and s minus d of by. Okay, and we have to show that this one for any epsilon, this one whole. Okay, B subset of this one. And obviously then we prove that U cross V is open in, then we cross U cross V is open in XY, but here this one is not related. Here is related this one, BXR cross BYS is open in X Cartesian product Y. Here if you put U this V this, then this one is happen. Okay, we have to show. Now we prove these things by help of this hints. How we prove it? We prove simply that first we let this one, then find epsilon. That means we have to find epsilon, and here also epsilon is given. Epsilon is given, and we take this picture also. This picture here, this one is a rectangle, and xy is be any point, and ab be any point here. Okay, then this one is b, this one is a, this one is x, and this one y. Okay, then this one and this one, s minus d of vy. That means this distance is s minus, this is s minus d by, and here obviously epsilon equal to minimum of r minus, here r minus d of ax, this one r minus d of ax. Okay, so if x, then this one and this one is r, and this one and this one is s. This is r, but this one is r minus d of xy. We take, then this one obviously become a solution. Okay, when become a solution, we take epsilon equal to this, we take this one become a solution. We have to show that this one, for epsilon greater than 0, solution. Okay, that AB belongs to this, then first is this one, for that epsilon equal to minimum of r minus d of ax and s minus d of by. Okay, then we prove that AB belongs to, then we proved and show that AB belongs to AB epsilon subset of PXR Cartesian product BYS. Okay, then what we show? Then we show that BXR Cartesian product BYS be open in X cross Y. Okay, totally X Y be two places, then open because we take one point and getting one neighborhood and getting this set. That means this set is open in X cross Y. Okay, then we solve these questions also. Now we discuss about next thing is similar way just to change this one. It's write uv any open set and u cross v be open in X cross Y. Okay, same thing, we let it turn another way, or we write it this one equal to u, this one equal to v, then we cross it, then we done it. Okay, then we done it. So u cross v, if we construct uv be any open set, u be any open set in x and v be any open set in y, then this one is done. But we write it. Okay, this one I understand, we understand also. Now we're going to further discussion. Then in further, we let the question first. Question be, let xy be matrix spaces, xy be matrix spaces. Okay, then consider the product space x cross y. Consider the product space x Cartesian product y with product matrix, okay. Then u be open in x, let uv are open in x comma y respectively. Okay, then we have to show that u Cartesian product v be open in x Cartesian product y. Okay, how we done it? This one is very simple. We take xy belongs to this u Cartesian product v. Okay, then choose epsilon greater than 0 such that bx epsilon subset of u and by epsilon subset of v. Now xy belongs to bx comma epsilon cross by comma epsilon subset of u Cartesian product v. Okay, then we done it. We write u Cartesian product v be open in x cross y. Okay, now this is done. So we're going to further step. We erase this completely. All understand these things. We just see about that product matrix. Our product spaces are open in Cartesian product of x cross y. Now we see about that. Now write in question form, let w be subset of x Cartesian product y be open in product matrix. Then let phi x and py denote the projection of x Cartesian product y onto x and y respectively. Then we have to show that pxw and pxw comma pyw be open or are open in x y respectively. That means this one is open in x, this one is open in y. Okay, how we prove it? We just draw this picture here. This one is the set, this one, okay, this one w x cross y, this one is pxw, this one is pyw. Okay, here x, here y, and we see that projection of w on x and y. We write it, projection of w on x and y. Now we write this one. We have to see that pxw is open in x. How we see that? We just take it. That means we just take it, this projection. Okay, we just write it, this projection, and now we prove that projection of w are open in x. How we prove it? Simply we take some point. This one is x, that means some point in pxw. Okay, then this one is how this one is formed. This one is open in x. That means we have to form that one point, write it, x belongs to pxw. Then we find some ball. That means for epsilon greater than 0, x belongs to some bx epsilon subset of pxw. Okay, then we have to show that we have right now we have write that pxw be open in x, and similar way we prove it. That means here y coordinates are 0. Okay, x means here x 0. Okay, write it, x equal to x 0, y coordinate are 0. And in similar way, if we write any problem, in this format, let y belongs to pyw. Here y means 0y. Okay, then for delta greater than 0, y belongs to by delta. Okay, by delta, this y belongs to by delta subset of pyw. Then pyw be open open in y. Okay, in this way we prove it. In this way we prove this one. So today stop here.